Next, let's talk about redundancy and fault tolerance. When we are looking for how to achieve fault tolerance or achieve a level of redundancy, what we're looking for are single points of failure, any single component or entity that will disable an entire system if it no longer functions. You want to remove any identified single point of failure. This is the primary mechanism to ensure business continuity. During the BIA process, the organization will identify tolerable downtime, whether they're looking for 90% uptime or up to 6 nines, you'll see it identified uptime. It completely depends on the organization's appetite for risk. Redundancy and fault tolerance is the next way to address single points of failure. With redundancy planning, we're looking at applying these to servers, storage, networks, powers, and alternate sites themselves. Remembering servers, for instance, play a key role in network infrastructure. Failure can have significant business impact. Some organizations actually will stockpile parts for servers or have whole redundant servers ready and waiting in case of failure. Others take a more proactive approach and will do server clustering. There are two types of server clusters, asymmetric and symmetric. Asymmetric servers perform no function except to be ready if needed. However, with symmetric servers, all servers do useful work. If one server fails, remaining servers take on the failed server's workload. You often see this used for web and media and VPN servers. Next is your hard drives. Often these are the first components to fail. What you're looking for is the mean time to failure. This measures the average time until a component fails and must be replaced. To combat hard drive failure, we employ RAIDs, or redundant array of independent devices. It uses multiple hard disk drives to increase reliability and performance. The Security Plus examination expects you to know and be able to identify several different types of RAID configurations, starting with RAID level 0, which is a striped disk array, but it provides no fault tolerance. If one drive fails, all the data on that drive is lost. Next, we have RAID 1, which provides mirroring. Disk mirroring is used to connect multiple drives to the same disk controller card. The primary drive can fail and data will not be lost. With RAID 1, you can choose to disk duplex. It's just a variation of RAID level 1. This time, however, you're going to use separate cards for each disk. This protects against controller card failures. Next, you have RAID 5. This is probably the most common and most popular RAID configuration. A series of independent disks with distributed parity. Data stored on one drive and its parity information stored on another drive. RAID 5 provides the highest level of fault tolerance. Next, we have redundant networks. These may be necessary due to the critical nature of connectivity today. Essentially, it's a network in waiting. It waits in the background during normal operations and then launches automatically in the event of any type of disaster. Many organizations contract, for instance, with a second internet service provider as a backup to the primary service. Next are UPSs, or uninterruptible power supplies. They maintain power to the equipment in the event of an interruption. You have a couple choices, either offline UPSs, which are the least expensive, which begin supplying power quickly when the primary power is disrupted, or online UPSs. They're always running off its battery while main power runs the battery charger. It's not affected by dips or sags in the voltage and can serve as a surge protector. They can also communicate with the network operating system to ensure an orderly shutdown occurs. Or you can opt for a backup generator, usually powered by diesel, natural gas, or propane. Next, we'll talk about the different types of backup sites and locations. It's a site necessary if, for instance, a flood or a hurricane or other major disaster happens to your primary building. Again, you have several options to choose from, starting with the hot site. The hot site is a duplicate of the original production site. It has all the needed equipment there, usually run by a commercial disaster recovery service. Data backups can be moved quickly to the hot site like location. Or you have the cold site. It provides basic office space. However, it takes longer to resume full operations. It is a lot less expensive than the hot site, but it really all depends, again, on the organization's tolerance for risk and how long can they be down before the organization and the business is unrecoverable. There is a middle ground, however, and that would be the warm site. The warm site has all the equipment already installed, but no active internet or telecommunications facilities. It is, again, less expensive than the hot site. However, the time to turn on connections and install backups can be half a day or more.